Welcome to Tiny Rex Tales. Long before the first human footprint, Earth belonged to a different kind of master. From the red deserts of Pangaea to the lush valleys of the Cretaceous, this is the story of a 160 million year reign. It is an epic of devotion, a masterpiece of survival, and a testament to the unyielding spirit of life itself. Welcome to the world of the dinosaurs. To reconstruct the lives of long-extinct giants, behavioral paleontologists act as scientific detectives. They don't have video footage. Instead, they assemble a story from fragmented clues left in the dust over millions of years. 200 million years ago, Pangaea was a wild, scorching wilderness where dinosaurs first emerged as pioneers. Fossilized footprints are more than just depressions in stone. They are snapshots of ancient movement. By calculating the distance between strides, scientists can determine the precise speed and locomotion of a dinosaur in its final moments. Coprolites provide the most direct evidence of prehistoric diets. Within these fossilized droppings, tiny fragments of bone, scales, or fibers reveal whether a species was a specialized carnivore or a wandering herbivore. Bone pathology tells a story of survival and aggression. Healed bite marks and fractures are biological records of territorial disputes, failed hunts, or the brutal reality of intraspecific competition. Decoding behavior requires understanding the environment. Reconstructing the climate and flora of the Cretaceous allows scientists to explain why certain species evolved specific social strategies to dominate their ecological niches. The apex predator, Tyras, favored the solitary ambush, relying on raw power and a devastating bite force. This giant utilized its acute senses to surprise prey in one explosive, lethal encounter. In contrast to solitary giants, smaller predators like swift relied on pack hunting. This social strategy allowed them to coordinate attacks, surrounding and overwhelming much larger prey through collective discipline. The hunt extended beneath the waves, where specialized predators like Thaler ruled. In the murky depths of the seaway, survival depended on the ruthless efficiency of sensory perception and aquatic speed. Biological weaponry was refined over millions of years. Every serrated tooth and curved talon was a functional tool designed for specific kill methods, whether through crushing bone or slicing flesh. The art of hunting was a balance between energy expenditure and reward. Predators had to calculate every strike, as a failed attempt could lead to starvation in a competitive, unforgiving world. Survival for herbivores often meant becoming a mobile fortress. Species like iron evolved heavy bony armor, transforming their entire backs into an impenetrable shield against the crushing jaws of predators. When armor wasn't enough, some chose counter-aggression. Bueller's massive horns were not just symbols of power, they were specialized weapons for face-to-face combat, capable of inflicting fatal wounds on any attacker. For the Stegosaurus, defense was a multifunctional display. The plates on its back served as a visual warning, while the spiked tail, or thagomizer, acted as a high-velocity melee weapon in close quarters. Herd behavior was the most effective social shield. By moving in massive groups, herbivores like hadrosaurs increased their chances of detecting threats early, turning the individual's weakness into collective strength. Whether through personal fortifications or the safety of the crowd, herbivores were active participants in the prehistoric arms race, constantly adapting to the evolving tactics of their hunters. In the world of dinosaurs, visual displays were the tickets to survival and reproduction. The elaborate crest of Aurum was a biological billboard, designed to attract mates and signal health from great distances. These hollow structures were more than ornaments. They were acoustic signaling devices. By blowing air through the crest, Aurum could produce low-frequency bellows that functioned as prehistoric mating calls. Mating rituals often turned violent. Competition for social status and breeding rights was settled through direct combat, where rivals like Dome utilized thickened skull caps and bone-crushing head-butting matches. The massive frill of the Triceratops served a dual purpose. defense, and display. During mating season, these frills may have changed color or been flushed with blood to intimidate rivals and charm potential mates. From the ground to the sky, visual splendor was the universal language of continuity. These elaborate structures ensured that only the strongest and most vibrant individuals passed their genes to the next generation. The Maiasaura, or good mother lizard, redefined our understanding of prehistoric life. Their communal nesting sites function like giant nurseries, where mothers gathered to protect the next generation collectively. Evidence suggests that Maiasaura remained with their nests long after laying. This strict guarding and incubation period provided a vital shield for the fragile embryos against small, opportunistic egg hunters. The devotion did not end at hatching. Analysis of juvenile remains shows that hatchlings were nurtured in the nest, receiving constant care and food, until they were strong enough to join the herd on their own. This parental investment mirrors modern seabird colonies. It was a long, responsible journey, proving that for these giants, maintaining the lineage was as much about nurturing as it was about survival. From the silent bones and fossilized tracks, we have restored a masterpiece of life, a story not just of monsters, but of artists, warriors, and mothers who once dominated our planet. Fossil sites containing the remains of multiple predators around a single large herbivore provide a frozen snapshot of pack hunting. This suggests that species like swift used coordination to bring down prey many times their size. The puncture marks found on the hip bones of Triceratops match the unique spacing of Tyrannosaurus' teeth. This forensic evidence confirms that the king of dinosaurs possessed the strongest bite force of any terrestrial animal in history. Defensive maneuvers were often proactive. Bueller's herd would form a protective circle, with adults facing outwards and young kept in the center, a strategic formation mirrored by modern-day muskoxen. The specialized sickle claw on the second toe was not for running, but for piercing vital organs. Digital biomechanical models suggest it functioned like a biological grappling hook, locking the predator onto its struggling prey. Every kill site is a crime scene where millions of years have buried the evidence. Paleontologists reconstruct the final moments by analyzing the scattering of bones and the presence of shed predator teeth left in the carnage. CT scans of fossilized brain cases reveal that Tyrannosaurus had massive olfactory bulbs. Its sense of smell was so acute it could detect rotting carcasses or living prey from miles away, even in dense vegetation. Forward-facing eyes provided Tyrannosaurus with binocular vision and superior depth perception, a rare trait among large theropods. This allowed for precise strike accuracy, even in low-light conditions. The delicate bones of the inner ear suggest that many dinosaurs were tuned to low-frequency sounds. This specialization allowed them to communicate across vast distances, hidden from predators who could only hear higher pitches. Large eye sockets in smaller carnivores suggest nocturnal habits. While the giants rested, a secondary ecosystem of night hunters emerged, utilizing the cool air and darkness to their advantage. In the ocean, Thaler utilized a Jacobson's organ, similar to modern monitor lizards. By flicking its forked tongue, it sampled chemical particles in the water to track prey through the vast, murky blue desert. Social status was often visually displayed through vibrant coloration on head crests. These were not just for mating, but acted as badges of rank within the herd, preventing unnecessary physical conflict. Territorial boundaries were maintained through deep, infrasonic bellows that could be felt as vibrations in the ground. These sounds served as warnings to rivals, establishing a domain that stretched for hundreds of square miles. Scarring on the frills of Triceratops suggests non-lethal wrestling matches. These battles of strength allowed males to establish dominance without risking the survival of the entire group. Waterholes were neutral zones governed by an unspoken truce. Fossils found at concentrated water sources reveal how diverse species interacted, sharing limited resources during the harsh dry seasons. Preening and social grooming, common in modern birds, likely began with feathered dinosaurs. These behaviors strengthen pair bonds and maintain the insulation properties of their plumage. Juvenile T-Rexes occupied a completely different ecological niche than adults. Lean and long-legged, they were built for speed, acting as pursuit predators, while their parents relied on brute force ambush. Camouflage was the first line of defense for the young. Hatchlings like Eldra's young likely possessed dappled skin patterns, blending into the dappled light of the forest floor to hide from keen-eyed predators. Chess, or communal nurseries, allowed a few adults to guard many young. This freed other parents to forage for the massive amounts of vegetation needed to sustain their giant bodies. Once misnamed egg thieves, fossils now show oviraptors died protecting their own nests. These specimens are found brooding over their eggs, a poignant testament to parental sacrifice during sudden sandstorms. Growth rings in dinosaur bones, much like tree rings, show that these creatures grew at astonishing speeds. Some reached adult size in less than a decade, a rapid race to maturity to escape the size-bias predation of the Cretaceous. Volcanic activity shaped many dinosaur habitats. The ashen-rich soil led to bursts of lush vegetation, forcing herbivores to migrate frequently and carnivores to follow their wandering larders. Evidence of dinosaurs in polar regions suggests an incredible tolerance for cold. Thick coats of downy feathers and the ability to slow their metabolism helped them survive months of twilight during the Arctic winter. The rise of flowering plants triggered a co-evolutionary revolution. Dinosaurs had to adapt their digestive systems and feeding behaviors to exploit this new, nutrient-rich food source appearing in their world. Coastal ecosystems offered abundant resources, but frequent dangers. Tidal fluctuations forced dinosaurs to develop swimming skills and foraging patterns that were timed with the rhythm of the ocean. At the height of their reign, dinosaurs were the masters of adaptation. Their behaviors were as complex as the world they inhabited, a vibrant masterpiece of evolution before the final curtain fell. The evolution of Ether, the Spinosaurus, represents a radical departure from terrestrial life. With a sail-like neural spine and a streamlined body, this titan conquered the river systems of North Africa, exploiting a semi-aquatic niche untouched by other large theropods. Specialized conical teeth and pressure-sensitive receptors in its snout allowed Ether to detect the movement of aquatic prey in murky waters. This biological sonar made it a master of the strike, bridging the gap between land and water with surgical precision. Territorial boundaries in these ancient deltas were fiercely guarded. Ether's massive sails served not only for thermoregulation but as a visual deterrent, signaling its dominance to any rival predators venturing into its watery kingdom. Seasonal shifts triggered massive migrations across thousands of miles. Fossilized trackways covering entire regions suggest that these herds moved with a synchronized discipline, driven by the search for new grazing grounds and stable nesting sites. Within the herd, Bueller practiced complex social cues to maintain order. Vocalizations, combined with rhythmic movements of their massive frills, allowed them to communicate warnings or coordinate movements during nighttime maneuvers. Migration was a brutal test for the young. Footprint evidence shows that juveniles were often placed in the inner tracks of the herd, protected by the heavy footfalls of adults who buffered them from the wind and mud. The osteoderms of iron were more than just bone. They were a complex lattice of mineralized tissue. This natural biological armor could absorb and redistribute the force of a T-Rex's bite, rendering the predator's primary weapon ineffective. The tail club was a marvel of biomechanical engineering. Driven by massive base muscles, it could swing with enough velocity to shatter the metatarsals of any predator, effectively crippling an attacker with a single, well-timed blow. For Bueller, the best defense was a coordinated offense. When cornered, the herd didn't just stand still. They engaged in a rhythmic stampede, a wave of multi-ton muscle and horn designed to trample anything in its path. A high encephalization quotient suggests that Swift possessed advanced problem-solving skills. They weren't just fast. They were capable of evaluating the environment and using cover to mask their approach during complex group ambushes. Stealth was a calculated choice. By mimicking the movement of wind-blown foliage, these feathered hunters could get within striking distance of keen-eared prey, proving that intelligence was as vital as claws in the hunt for survival. The Truden, with the largest brain-to-body ratio, utilized the cover of night. Their superior intelligence allowed them to develop nocturnal hunting patterns, exploiting the vulnerability of larger dinosaurs that were nearly blind in the dark. The thickened skull caps of Pachycephalosaurus were likely adorned with vibrant skin patterns during the breeding season. These displays allowed males to size each other up, often resolving disputes through visual intimidation before resorting to physical impact. Fossilized injuries on Bueller's frill aren't signs of failure, but markers of experience. Each healed wound established a hierarchy within the herd, ensuring that only the most resilient individuals assume leadership roles during times of crisis. Communal nesting grounds were rare but significant sites of interspecies tolerance. During the peak of the breeding season, diverse groups would share favorable geological locations, prioritizing the safety of the next generation over territorial rivalry. The dental battery of the Edmontosaurus was a masterpiece of biological grinding. Hundreds of teeth worked in unison to pulverize tough, fibrous vegetation, allowing them to extract maximum nutrients from the most resilient plant life of the Cretaceous. Many long-necked giants swallowed stones, or gastroliths, to aid in digestion. These stones acted as a biological mill within the stomach, grinding down massive quantities of unchewed foliage that their teeth alone could not handle. The environmental impact of a feeding herd was profound. Large herbivores acted as ecosystem engineers, clearing vast areas of forest and allowing sunlight to reach the floor, which triggered the growth of new, diverse plant species. Volar's flight was a delicate balance of aerodynamics and sensory input. Specialized fibers in their wings, called actinofibrils, allowed them to adjust the wing's tension in real time, maneuvering through turbulent coastal winds with ease. On the ground, the Quetzalcoatlus was a formidable predator. Its massive head and colorful crest were used for ground-based displays, establishing dominance over land territories and scavenging sites once ruled solely by theropods. Carcasses were the focal points of intense social drama. Scavengers didn't just eat. They engaged in a complex hierarchy of intimidation, where size, aggression, and speed determined who received the lion's share of the ancient remains. Feeding was a race against time and rivals. Every bite had to be efficient, as the smell of blood would soon attract larger, more dominant predators that could easily turn a scavenger into the next meal. As the Cretaceous drew to a close, dinosaur behaviors had reached a pinnacle of complexity. They had conquered every environment, from the deepest oceans to the highest skies, in a grand display of biological resilience. We see their lives not as static fossils, but as a vibrant film restored frame by frame. Every scratch on a bone and every track in the mud is a testament to a world that was as alive and dynamic as our own. But the ultimate test of survival was approaching from the stars. A cataclysmic event that would challenge even the most sophisticated behaviors and bring the age of giants to a definitive, fiery conclusion. While life on Earth reached its peak of complexity, a mountain of rock and fire was hurtling through the void. 10 kilometers wide and moving at terminal velocity, the Chicxulub asteroid was a cosmic reset button about to strike the blue planet. In the final hours, the environment whispered of the impending disaster. Unusual atmospheric shifts and a blinding streak across the daylight sky left the giants bewildered, their finely tuned instincts unable to comprehend a threat from the stars. The collision unleashed energy equivalent to billions of atomic bombs. In an instant, the Yucatan Peninsula was vaporized, sending a shockwave that flattened entire forests and triggered mega tsunamis that reshaped the world's coastlines. For Bueller and his herd, The world became a hellscape of fire. Ejecta from the impact rained back down as molten glass, igniting global wildfires that consumed the very ecosystems they had dominated for millions of years. Even the deep oceans offered no sanctuary. The massive displacement of water created tsunamis hundreds of meters high, while the sudden acidification of the surface layers began to shatter the marine food web from the bottom up. The catastrophe didn't end after the impact. A global shroud of ash and dust began to envelop the atmosphere, ushering in a harsh impact winter where sunlight became a distant luxury and temperatures plummeted globally. As sunlight failed to reach the surface, photosynthesis, the engine of the Cretaceous, world ground to a halt. The lush forests became silent graveyards of plants, leaving herbivores with nothing but dry stalks and ash. The apex predators were the victims of their own success. With the herbivores dying out, giants like Tyras found themselves at the end of a broken food chain, their massive bodies unable to sustain themselves on the dwindling remains of a lost world. The nurturing instincts of Eldra were put to the ultimate test. In a world without food or warmth, the good mother lizard stood over her cooling eggs, a final, poignant act of protection in an environment that no longer allowed for life. The herd, once a symbol of collective strength, became a gathering of shadows. Bueller, the guardian of his kin, stood motionless against the biting wind, a silent monument to a reign that was being erased by time and ash. While the giants perished, the small and adaptable found a way. Mammals like scurry, living in deep burrows and possessing omnivorous diets, were shielded from the fire and cold, surviving on the very debris of the fallen titans. The dinosaur lineage did not entirely vanish. Small, feathered survivors, the ancestors of modern birds, utilized their mobility and ability to feed on hidden seeds and insects to navigate the post-apocalyptic landscape. Locked within the Earth is a thin, dark line of sediment known as the KPG boundary. This iridium-rich layer is the physical ghost of the impact, a global marker that separates the age of dinosaurs from everything that followed. Every fossil we unearth is a frame recovered from a shattered film. By analyzing the healed wounds and social patterns of these creatures, we are essentially cold case detectives solving the greatest disappearance in Earth's history. As the dust finally cleared, the sun returned to a different world. The empty ecological niches left by the giants provided a vacant stage for the mammals to rise, diversify, and eventually dominate. From the shadow of the dinosaurs, a new lineage emerged. In just 10 million years, mammals transformed from scurrying burrowers into an astonishing array of forms, filling the forests, plains, and oceans once ruled by reptiles. We live among them still. Every time you watch a bird take flight, you are witnessing the enduring legacy of the dinosaur behavior, a lineage of warriors and mothers that survived the end of the world. Our fascination with them is more than curiosity. It's a recognition of life's resilience. Through science, we breathe life back into the stone, making the silent bones roar once more in our collective imagination. The story of dinosaurs is a lesson in the fragility of dominance. It teaches us that survival is not guaranteed by size or power, but by the ability to adapt to a world that can change in a heartbeat. We stand on the ruins of their empire, writing our own chapter in the book of life. The challenges they faced, environmental change, food security, and survival, are the same challenges we face today. They hunted with precision, fought with courage, and nurtured with devotion. They were the masters of Earth for 165 million years, leaving a legacy of resilience etched into the very crust of our planet. To touch a fossil is to touch deep time. It is a bridge between our world and theirs, a silent conversation between two civilizations of life that occupied the same stage millions of years apart. Nature's reset was harsh, but it was not the end. When the magnificent clock was shattered, the smallest surviving gears built a new, more intricate mechanism, one that led to us. The dinosaurs didn't just disappear, they became a part of us. Their story is our story, a testament to the enduring, unbreakable spirit of life on Earth. The Golden Age ended, but the journey continues. Dedicated to the giants who walked before us and the survivors who paved the way. Dinosaur behavior unveiled. The end. Thanks for watching. If you enjoyed this video, make sure to hit the subscribe button and drop a comment below.